We'll start in a minute. Okay. Um, so not too many people today, but thank you, Anam and Maham, and Taik Saab is here as well. Um, so we are going to just very quickly review what we did last time. So this chapter that we are covering from the book is about application layer protocols. We talked about HTTP in great detail. Um, so when we talked about HTTP, we talked about different versions of HTTP, how persistence and pipelining um, was incorporated in newer versions of HTTP to improve the efficiency of the underlying protocol. In fact, TCP sets some limitations. You have to first establish the connection, and then you can only do the transfer. Since HTTP uses TCP underneath, so some of the bottlenecks of TCP has to be compensated for by HTTP, and things like pipelining, persistence, and even the parallel TCP connections. We talked about that in detail. Then we also talked about caching. Um, so one of the other application layer protocols, which is pretty much central to all the networking applications, is the DNS protocol. HTTP, by the way, um, when you type an address in your browser and contact a server request for a web page, you will get a web page. Behind the scenes, the DNS might be running unless you specify the IP address in the browser window, browser address bar. Um, so when you type www.cnn.com, your browser behind the scenes will use DNS to translate that www.cnn.com into the corresponding IP address of a machine which is hosting the cnn.com's website. Okay, so very important job of DNS is to perform this translation from the host names to these IP addresses. Um, so far we have only talked about IPv4 addresses. We also have IPv6 addresses. The most prevalent ones these days are only are IPv4 addresses. some ISPs in Pakistan experimentally have started IPv6 as well, but very limited functionality available from them. Um, so mostly in this course, when we talk about addresses, unless we specifically talked about IPv6, we will be talking about IPv4, and DNS translation would also be limited to IPv4 address translation. So you have a host name, you want to translate that host name into the corresponding IP address. DNS is the service to do that. DNS is the protocol to basically translate these addresses like www.usc.edu um, or venus.lums.edu.pk, translation of these host names into the corresponding IP addresses. Now, you might also notice that these host names are sort of hierarchical, and that .edu tells you that it's an educational institution, then perhaps the name of the educational institution, and then www with that. Similarly, .pk tells you something that the host is in Pakistan, which is the top level domain. Edu is indicating that it's an educational institution, the name of the institution, and then the name of the machine inside that institution. So venus.lums.edu.pk is a machine, which is it's a real name, by the way. This is a machine which is hosted on LUMS campus. Another one would be suraj.lums.edu.pk, which is also machine which is very much in existence, used to host the course outlines. Um, so um, so translation from the host names to IP addresses is the job of the DNS. Okay, so basically it's a directory services. Why do we need to bother with that? Because it's easier to remember the host names as compared to the IP addresses, and also provides a level of interaction, which means that you decouple the names from the addresses. If you can change the IP address of your server, for whatever reason, you change the service provider, or you move from one location to another location, you can still keep the same domain name, same host name, and have a different IP address. So early days, we talked about that a single file will list all of these. Obviously, this is not scalable for the internet scale. Um, the kind of scale that we see on the internet, billions of devices. It's not possible to list all those in a single file. So DNS system was developed as a distributed system by 4 Berkeley students, um, to solve this issue of growing number of hosts on the internet. So the goals that are that it has to be scalable. There are many names, many updates, changes might happen, and many users who will be creating the names, and many users who will be looking up the name, many more users who will be looking up the names. And it has to be highly available. You can't say, sorry, I'm not available right now, so attempt some other time. It has to be available almost all the time, and has to be correct as well. I don't want the translation to be happening to a wrong machine. Sometimes it happens. It might be pertinent to point out at this time that if you go to a website which is, let's say, censored in Pakistan. So what might happen is, one possible way of censoring a website is that, when you ask for the name translation, that I want to go to www.forbiddenwebsite.com, the translation that you get from wherever you get it, that translation is for an IP address which is of a machine which does not correspond to www.forbiddensite.com. It is for a machine which is hosting a web page, and when you send the request to that machine, it returns a page to you and says that, sorry, you cannot access the website. The access to that website is prohibited in this country, or something like that. Everyone has seen that kind of message when you try to access some websites um, which are censored in the country. So what we do in that case is, your service provider, LUMS, for example, or your ISP or PTA at the country level, might make sure might make sure somehow that the DNS responses which are given inside the country, those DNS responses are incorrect, and they are incorrectly pointing to a machine which will say this, um, that you don't have access to www. Someforbiddenwebsite.com. Okay. Any questions so far? Quick question? No? Great. Okay. So we'll quickly move forward. So how do we achieve all of those things? Scalability, lots of users accessing the DNS system, lots of user updating it, lots of websites, etc. So it is done by means of distributed systems. So you partition the namespace. And distribute the administration of each partition. So for example, LUMS will be responsible, LUMS IST department will be responsible for making the translation. LUMS is authoritative for making the translation for all the machines, which belong to LUMS. And when we say belong to LUMS, means that they end with their names, host names end with lums.edu.pk. So suraj.lums.edu.pk, chan.lums.edu.pk. By the way, these are real names of the machine. abasin.lums.edu.pk, zambil.lums.edu.pk, lms.lums.edu.pk, and so on and so forth. So all of those machines, the name translation for that is the administration of that is the responsibility of LUMS. Nobody else does that translation. But you might wonder that people outside LUMS, they will need that translation as well. Why they will need that translation? So for example, somebody sitting in Europe wants to access www.lums.edu.pk, needs a translation for www.lums.edu.pk, but that translation is administered by and managed by LUMS campus. So somehow they will have access to these machines, which are the domain name servers, DNS servers, which are hosted on LUMS campus. Almost every organization, every mid-sized to large size organization will host a DNS server, which will be responsible for translating the host names corresponding to that organization into the respective IP addresses. Okay, so somebody sitting in Europe, somehow they will search. We don't know that search process. We'll find that out in a minute. Somehow they will search for a server who is responsible for translating www.lums.edu.pk into the IP address. And obviously that server is on LUMS campus. So they will come here somehow. And that process is basically the DNS query resolution process. Um, and we also distribute the name resolution for each partition. And the way that this happens is by means of these hierarchies, three intertwined hierarchies. And these three intertwined hierarchies are a hierarchical namespace, which is hierarchically administered, not centrally administered. Not just the namespace is hierarchical. So you have lums.edu.pk. See, if you read it in the reverse order, then it is PK means everything in Pakistan, then EDU, all the educational institutions in Pakistan, and then LUMS, which means the LUMS campus, and then venus.lums.edu.pk, this specific machine, Venus on LUMS campus. Okay. So it is hierarchically administered. LUMS will be responsible for the administration of those servers. And then there will also be a hierarchy of servers as opposed to a central storage. So servers will be distributed all over the place so that people can get the answers quickly. Okay. So the three hierarchies that we talked about, first hierarchy is about the namespace. You have the root namespace, and then you have these top level domains. We call them top level domains for countries, for military, for organization, for government, for .com, all the commercial organizations. Then educational institutions in the US, by EDU, and then you have country level domains, the UK for France, FR, for Pakistan you have PK, and so on and so forth. Okay. So within educational institution, all the educational institution, and you can see that this is a tree structure here. This is a tree structure And this tree, by definition, this tree structure will not have any cycles in this. And so the domains here are the subtrees. The domains are the subtrees. So for example, .edu, and then berkeley.edu, and eecs.berkeley.edu. So name is leaf to the root path. instr inster.eecs.berkeley.edu. So this is going from, in this direction, upward direction. ये root तक जा रहा है, ठीक है. root को लिखते नहीं है, but when you finish at the top level, domain. Okay. If you do so, then there are no name collision. No two servers will have the same name, because it's a tree structure. No two servers will have the same name. Each one will have their own responsibility. LUMS will need to make sure that there are no two Venus servers on LUMS campus. You don't have venus.lums.edu.pk and another venus.lums.edu.pk. Or you can definitely have venus1.lums.edu.pk and venus2.lums.edu.pk, but you cannot have two servers with the same name, venus.lums.edu.pk. Okay. So that was the hierarchy of the namespace. Then there is a hierarchy of administration, and the hierarchy of administration is really according to the namespace. So Berkeley is responsible for managing, for administering the namespace corresponding to Berkeley, and maybe within Berkeley you have subdivision that EECS department in Berkeley is responsible for their own thing. All the machines within the EECS department are managed by the EECS. Maybe there is a IT team for the EECS specifically. Similarly, you can also have physics.sse.lums.edu.pk. You see, it's very hierarchical in this way, and the administration can be divided in the same hierarchy. Of course, you can consolidate the administration as well. For example, you can say that LUMS IST department will handle everything in the namespace of LUMS. Instead of giving it to the departments, because the departments are too small. But if the departments are very, very large, as they might be at Berkeley, the EECS department is very large. So they may delegate the administration from the central IT department to the EECS department. So very, very open to flexibility. Okay, so the TLDs and the root servers are managed by this numbering agencies called ICANN and INA. Similarly, Berkeley will handle Berkeley and everything under that, and EECS might have a separate administration. Okay, you also have server hierarchy at the top. We have root servers and TLDs, top level domains. So these locations for the root servers, they are hardwired, and the reason they are hardwired is sometimes you have to access the root servers. Almost rarely you access the root servers, but because you have cached the top level domain name servers, almost everyone would have cached that. Okay, but sometimes you have to access the root name servers. And next are the top level domain servers. These are also managed professionally, .com and .edu and the country domains. PKNIC, for example, handles the domain name registration for the domains in Pakistan. Okay, at the bottom level of the hierarchy, what we have is called authoritative DNS server. So authoritative means that who have the authority for managing the site. So for example, venus.lums.edu.pk, the authoritative DNS server for that will be a DNS server which is hosted within LUMS. जो LUMS का अपना DNS server है वो उसको manage कर रहा होगा, unless LUMS outsources that, which it doesn't, by the way. LUMS has a few DNS servers on campus. We do have DNS servers. By the way, these DNS servers are pretty much very simple software. Open source is available. You can run a DNS server on your own. आप भी run कर सकते हैं. Yeah. So then you have these server hierarchies. We talked about that last time. So basically, DNS root, it's located in Virginia. It's located in Virginia, and as we said, that it's not just one server. It's not one hierarchy. You have this root name server replicated at lots and lots of places. There is a couple of at least one in Pakistan. I think maybe F or M, I forgot which one. So one of the root name servers, um, these are A, B, C, D, etc. These root name servers, but these are pretty much the replications of the same root, replication of the same root. So for more details, we encourage you to visit this www.rootservers.org. So these 13 root servers, and by the way, once again, these are not 13 machines. These would be much more than 13 machines, replicated machines. So A root server, B root server, C, all the way up to M root servers. Each one of them will have replicas, and one of those replicas for one of the root name servers is in Karachi. Is in Karachi. I think we probably might have two now. I'm not entirely sure, but there is at least one. So, for example, you can see that there is redundant location. J root name server has 21 locations across the world. EF name server has 37 locations replicated across 37 locations across the world. Um, so all of this replication is done via what we call anycasting. Anycasting. So anycasting is a very cute idea, I would say. Anycasting means, remember the goal in networking and communication networks is to make sure that a source is able to send the packets to the destination. A source is able to reach a destination. Two machines are able to communicate with each other. Um, so both of these machines, A and B, they are able to talk to each other, able to reach each other. There can be many switches and links in between. So what is Anycast? Anycast means that we have lots and lots of these root name servers, but we really did want just one root name server. Okay, एक ही की जरूरत थी, हमें एक ही की जरूरत थी. हमें लेकिन इतनी सारी रेप्लिकेशन हुई है. So what we do in this case is ये रेप्लिकेशन के अंदर हम Anycast यूज कर लेते हैं. And by the way, you can use Anycast for your machine. So for example, if you have a machine that my personal machine dot my name dot edu dot pk, something like that, you can replicate that machine and you can have users access to both the machines in a load balanced way. So let's say if you have two machines with the same host name, you want to give them both the same IP address. Can you host them on the internet? The answer is, typically the answer would be no, but we might still be able to do that if you want to implement Anycast. And what that means is that you have multiple machines, all of them doing the same thing. If you reach any one of them, your job is done. If you reach any one of them, your job is done. That is called Anycast. Okay. And in DNS, all you need is a translation. I want a translation from this host name to an IP address. I don't care who makes that translation, this root name server or this root name server or this root name server. So Anycast is a paradigm which is very suitable for this kind of a situation. So routing will find the shortest path to the destination. And here, mind you, there is not just one destination. Why there is no one destination? Because I don't care where the destination is. These root name servers, numerous of them scattered throughout the world. If the guy in Karachi is responding to my query, I'm asking, translate www.cnn.com for me. If the root guy in Karachi is making that translation, I don't care where the rest of the root name servers are. If there is no server in Karachi, somebody else will do the translation for me. If I can't reach the server in Karachi, somebody else will do that translation for me. So I will need to find the route. I will need to find the route or shortest path to one of those root servers who will do this translation for me. So what happens if multiple machines claim to have the same address? If they claim to have the same address, then remember what we said in case of routing, that if you want to send a packet to a destination, you put the destination IP address inside the packet and send it off. And then the routers on the way, they make sure that they open the packet, get the destination IP address, match it into their tables, and send it towards the close towards the right destination. Okay, what if multiple machines could be possible correct destinations? So this guy has an IP address and another guy has the same IP address. So one guy in Pakistan has that IP address, one guy outside Pakistan has that same IP address. You can reach either of those machines if they are providing the same service to you. If they are providing same service to you, that is the case with the root name server. So the next chapter, in fact, not the next chapter, the one after that, we will see that these machines, the way that this routing works is that these machines claim, they advertise that I have this IP address, and they advertise it to the rest of the world. That is how all the routers in the world, they figure out that, hey, that machine has this IP address, so let's store it in our tables so that later on, if we see a packet destined for that machine, we know where to send it. Okay, so very interesting situation. Okay, if I have a machine which has an IP address, it's the responsibility of this machine. If it wants to be reached, it's the responsibility of this machine to tell the rest of the world that, hey, this is my IP address. If you want to send a packet, send it to me. Okay, so तो वो ब्रॉडकास्ट कर देगी, वो सबको पूरी दुनिया में बता देगी कि ये मेरा आईपी एड्रेस है. रास्ते में जितने राउटर्स आएंगे, इनफैक्ट सारे राउटर्स आएंगे, वो अपने पास मेक श्योर कर लेंगे कि ये नोट कर लें अपने टेबल्स के अंदर कि ये मशीन का आईपी एड्रेस है, इसको ऐसे रीच कर सकते हैं. एंड देन later on, when somebody throughout the world wants to reach that machine, then what they would be able to do, they will send a packet, and all the routers, since they already know where that machine is, वो उसको सही रास्ते के ऊपर भेज देंगे. Okay, what happens if multiple machines claim to have the same address? If they claim to have the same address, the routers may get confused. Generally, they don't get confused. If two guys are claiming the same thing, the router will say, okay, we'll just send it to one. They will make this decision somehow based on certain parameters that we will learn in the chapter after the next. Okay, so the network will deliver the packet to the closest machine with that address. The network will ensure, we will see that in the chapter on routing, that the network will deliver the packet to the closest machine with that address. And this is called Anycast. Which means that I reach any of these machines. This is very, very robust mechanism, does not require any changes to your traditional routing algorithm. So very, very interesting way of reaching the machines. So another example of Anycast would be www.cnn.com. They have, let's say, they have a server in New York. They plan to host few servers throughout the world, one in Karachi. So if I send a request to www.cnn.com, it will get translated to an IP address, and that IP address is the same throughout the world. I'm not talking about a domain name having multiple IP addresses. That is also possible, by the way. That is also possible, but that is different from Anycast. Okay, so Anycast, one domain name will have one IP address. Okay, you can also have one domain name translated into multiple IP addresses, okay, for load balancing purposes. But you can also do load balancing by using this Anycast, and if CNN.com has a machine in Karachi with the same IP address, then the packets that you send from your machine, when you send a request to www.cnn.com, those packets will land in Karachi rather than going to New York. Okay, so now coming back to DNS, the way that DNS works is that you send a request to the DNS server. By the way, every machine will have the DNS servers configured as part of their network configuration. ये necessary है. So if you open up the network properties of your machine, you will be able to see that there is an IP address, a mask. We'll talk about mask in the chapter of the next. And then there will be a default gateway. And that default gateway is basically the router which will connect you to the rest of the world. Okay, default gateway has to be there. And then you also have to have the DNS servers, and not one, but at least two DNS servers, okay, for robustness. So these DNS servers, they store what we call resource records. So anyone who contacts these DNS servers, they will return the resource record. वो कहेंगे यार ये record है हमारे पास, ये ले लो, ठीक है? And the way the format, the resource record is formatted is it has these fields, which is there is a name field, and then there is a value field, then there is a type field, then there is a TTL field. Okay, I will explain that in a second. Okay, the name field is basically the server name that you want to translate. Could be venus.lums.edu.pk, could be www.cnn.com. That would be the name. Okay, and the value would be its IP address. Value would be its IP address. So what we have learned in DNS is that you do translation from the name to IP address, name to IP address. So all you need is this name and the corresponding value. Okay, and these type of records are called the authoritative records, authoritative A-type records, address type records. Authoritative servers keeps these A or address type records, A-type records. This field, which is TTL, that tells you for how long this record is valid, time to live. So maybe this is good for the next 2 months, maybe good for next 2 hours, maybe good for next 2 years. Okay, so time to live is the information, gives you the information that this record is valid for so long. So when you send a request to a DNS server, the DNS server will return you the resource record. ठीक है, उस रिसोर्स रिकॉर्ड में आपका जो आपने नेम भेजा था वो होगा, और साथ उसकी कॉरस्पॉन्डिंग वैल्यू होगी, साथ उसकी टाइप भी होगी. टाइप की हमें क्यों जरूरत पड़ती है? हमने तो कहा कि DNS is basically for translating host names to IP addresses. तो टाइप की क्या जरूरत पड़ गई? So we'll see कि टाइप की हमें क्यों जरूरत पड़ गई. So first, which is the most common, is the A type or address type records, A or address type records, in which you provide the host name, and that host name is by the way included in the resource record that returns back to you. आपने DNS की जो रिक्वेस्ट भेजी उसके अंदर आपने लिख दिया venus.lums.edu.pk. जो आपको रिकॉर्ड आया उस रिकॉर्ड के अंदर भी लिखा हुआ है venus.lums.edu.pk, and then also an IP address. An IP address is included in that. Okay, we had a very small exercise जो homework के लिए दी हुई थी, was due yesterday, जिसमें आपने DNS के साथ कुछ थोड़ा play किया होगा. Okay, so A type record, and then we also have this NS or name server type of record. Now name server type of record जो है, job of that is basically translation of a domain into a corresponding DNS server for that domain. Okay, why is this needed? This is needed because think about it. venus.lums.edu.pk. Who makes that translation? The IT department in LUMS makes that translation. लेकिन एक बंदा कोई बाहर बैठा हुआ है, उसको क्या पता हमें या IT डिपार्टमेंट में किस मशीन को जाके पूछना है? उसने LUMS के नेम सर्वर से पूछना है. तो बेसिकली वो ये देखेगा कि whether they want to go to venus.lums.edu.pk or www.lums.edu.pk or mail.lums.edu.pk, anything.lums.edu.pk जाना चाहते हैं वहां पे, वो कहेंगे oh this is finishing with lums.edu.pk, so let me go and ask someone कि who is responsible for translating anything.lums.edu.pk. anything means कुछ भी, कोई भी हो सकता है, Venus हो सकता है, सूरज हो सकता है, ठीक है. So lums.edu.pk पे end होने वाले all the host names, who is responsible for that translation, and that is your name server guy. तो ये उनको पहले पता चलेगा. फिर जब इसका पता चल गया, फिर वो इससे पूछेंगे कि भाई venus.lums.edu.pk, please do that translation for me, and this guy will be able to do that, will be happy to do that translation. But first you need to figure out कि who is that name server who can do this translation for you. सबसे पहले उस नेम सर्वर को तलाश करना पड़ेगा, जिसके लिए आपको ये NS टाइप का रिकॉर्ड चाहिए. So there is another record which is called canonical name record, and the reason that this exists is because you can have name as the alias name for a host. Remember हमने कहा था resource record में एक name होती है और एक value होती है. तो name जो है is the alias name, easy to remember name होगा आपके पास, और वैल्यू जो होगा कैनोनिकल नेम, ये होगा बहुत डिफिकल्ट सा कोई नाम होगा, दैट router 347 dash New York dot Manhattan dot something dot AT&T .com और उसका एलियस नेम होगा कि एक बंदे ने रखा होगा कि जी server managed by john.com or something like that, you know. So alias name for that host, easy to remember name hoga from a more difficult kind of a name. Yeah. Then finally we also have this mail exchanger type of a record, MX record, and name in this case in the resource record is the domain in the email address, and the value is the name of the email server. Okay, so for example, if you have if the name is stanford.edu, then the value could be mail03.stanford.edu. This is the host name of a machine which is hosting a mail server, and the reason that there is a separate mail record, separate type of record, MX type of record for that, is you can also have www.stanford.edu. It is not a good idea to have email addresses like john@mail03.stanford.edu. It's not a good idea to have. So you would like to have john@stanford.edu. Okay, you would like to have record tariq@lums.edu.pk. Okay, this lums.edu.pk, this really is a domain. How do you find out which machine is hosting that mail server? In order to find out which machine is hosting that mail server, you need this MX type of a record. Now there is an example. How do you insert the resource record in the DNS? कैसे डालते हैं इसके लिए? So it's a very practical example. You might run into this sometime at some point in time if you have to host a machine. So suppose that you just created a company, fruit chart के नाम से कोई company बनाई है. So you get a block of IP addresses from your ISP. So when you get the network connection from your ISP आपको दो चीजें देता है. एक तो bandwidth देता है, physical connectivity, and the bandwidth on that also provides you an IP address. You can get a block of IP address. एक single भी ले सकते हैं, लेकिन generally you would like to get a block of IP address. आपने कंपनी बनाई है तो 8-10-12 मशीनें होंगी. 8-10-12 मशीनों के लिए आपके पास IP addresses होने चाहिए. So those IP addresses, you will get a block. So this represents a block of IP addresses. /25 means the first 25 bits of 212.44.9.128. Remember हमने कहा था कि हर octet को आप 8 bits में convert कर सकते हैं. So first 25 के अंदर ये 3 octets पूरे आएंगे और फिर एक bit जो है वो 128 की आ जाएगी, which is 100000. So last वाली जो है वो कुछ भी हो सकती है, which means that this block contains lots of hosts. We will have more detail on this in the chapter after the next chapter. जब IP addresses पे पढ़ेंगे chapter उसमें और detail आएगी, लेकिन this is a block of IP address. Let's say you get this block of IP address which contains these addresses, 128 wala, 129 wala. So you want to register fruitchart.com because somebody coming to fruitchart.com should be able to come to your website. Okay, so you register this domain name fruitchart.com at a registrar, and these registrar could be many companies hosted in Pakistan. GoDaddy is a global one, very famous. Lots of people do that. तो $10-12 का जो है ये 1000-1500 रुपए का ये रजिस्टर हो जाता है. ठीक है. So you provide the registrar को आपने बताना पड़ता है with the names and IP addresses of your authoritative domain name servers. क्यों बताना पड़ रहा है? इसलिए बताना पड़ रहा है कि anyone coming to any machine on your network will ask your DNS server for that translation. बिल्कुल उसी तरह जैसे somebody wants to go to venus.lums.edu.pk, they want to access the IT folks. They want to ask the IT folks at Lums के please हमें ये translation कर दो. ठीक है. So they need to know the address of the DNS server. So DNS server का उन्हें address चाहिए होता है. So registrar will insert the resource record pairs into the .com TLD server. ये TLD server में डाल देगा, fruit chart के corresponding TLD server में डाल देगा. ये कौन से record डालेगा? एक तो name server वाला record डालेगा, which means that anyone in the world, when they want to make the translation, they will go to the root से कहेंगे भाई मुझे .com का पता बता दो. रूट जो है .com का पता बताएगा, फिर वो .com के पास जाएंगे, उससे कहेंगे भाई आई वांट टू गो टू submachine.fruitchart.com, तो वो TLD सर्वर कहेगा कि भाई I don't have that translation submachine.fruitchart.com. However, what I can do is I can tell you that fruitchart.com, there is an NS type of a record. That means this dns1.fruitchart.com, this is the machine who will translate everything for you corresponding to fruitchart.com, about fruitchart.com. And by the way, the IP address of the dns1.fruitchart.com is this. ये जो दो records हैं ये TLD सर्वर के अंदर चले जाएंगे, TLD सर्वर में चले गए, और उसके बाद you will store the resource records in your server dns1.fruitchart.com, जो आपके डोमेन पे होस्ट हुआ है, आपने खुद उसको होस्ट किया हुआ होगा अपने नेटवर्क के ऊपर. टाइप a record for www.fruitchart.com, ठीक है, and type mx record for fruitchart.com, okay, so that people can send you email as well. This is a very simple view. Very quick review of how the DNS query will be resolved. So this is the client application view. By the way, when we say client application view, which means that your browser might be doing that behind the scenes. So a client code hoga wahan pe, that code will be performing this translation for you, application. So this has two components. There is a local DNS server and then the resolver software on the host machine. And to give you an example, you will contact this local DNS server, and this local DNS server which is configured in your network settings. अगर आपने खुद सेटिंग नहीं की है नेटवर्क की, तो these settings are given to you by default. When you turn on the machine, your machine will automatically from your network will get a block of network configuration, which is your IP address. You get your IP address, your mask, your default gateway, and the DNS servers. ये सब कुछ नेटवर्क कॉन्फ़िगरेशन आपको जो है by using a protocol जो अभी हमें पता नहीं है, DHCP एक प्रोटोकॉल होता है. So when you turn on the machine, DHCP protocol is the one which will give you all of this information कि ये आपके नेटवर्क कॉन्फ़िगरेशन के अंदर डाल देगा, ठीक है. So the client application, for example, the browser on your machine obtain the DNS name, for example, from the URL, वो DNS name निकालेगा and triggers the DNS request to the local DNS server. To exemplify that, let's consider the example here. Okay. We have the root servers, edu servers, TLD server, and then nyu.edu server, New York University का कोई server है. So let's say I am sitting on LUMS campus. This is LUMS campus here. This is LUMS campus here, and I'm sitting on LUMS campus. And in my browser, I type some address, some machine pink.nyu.edu, okay, which means there is a machine on NYU's network, but I need to find the IP address of that. So my laptop.lums.edu.pk, in the browser, when I type that in the address bar, that pink.nyu.edu, that DNS client included within my browser's code, that DNS client will ask the local DNS server. Local DNS server, ये local DNS server उसको पता कैसे चलेगा कि local DNS server है? नेटवर्क कॉन्फ़िगरेशन से पता चल जाएगा, which is dns.lums.edu.pk. उससे पूछेगा कि भाई please translate, make the translation for me, www.nyu.edu or pink.nyu.edu. Please can you do this translation for me? Okay. If this guy dns.lums.edu.pk has previously cached the response, कभी किसी और ने पूछा होगा, उसने हो सकता है कैश किया हो, लेकिन हो सकता है ना कैश किया हो. अगर कैश किया होगा तो वो यहीं से जवाब दे देगा. अगर कैश नहीं किया हुआ तो क्या करेगा, वो रूट से पूछेगा. वो कहेगा प्लीज ट्रांसलेट www.nyu.edu for me because I want to answer this guy. So this local DNS server will ask the root DNS server. Root DNS server will say, okay, oh, I am the big guy. I don't know these kind of small translation. However, I can help you. I can tell you that these .edu servers, there is an IP address corresponding to these .edu TLD servers. You can ask them. Okay, and the query will be forwarded to .edu servers. And then .edu servers, they will not have the answers either. They will need to ask the .nyu.edu server. उनके सर्वर्स पे जाएगा, नेम सर्वर्स पे जाएगा, उनसे पूछेगा कैन यू प्लीज डू दिस ट्रांसलेशन. नाउ दिस गाय विल नो द ट्रांसलेशन, बट इज द ट्रांसलेशन फॉर www.nyu.edu. वो उसको ट्रांसलेशन वापस करेगा, ये वहां से रूट की तरफ आएगा, एंड देन वहां से हमारे लोकल सर्वर पे आएगा, और लोकल सर्वर जो है वो मेरे क्लाइंट को जवाब दे देगा. नाउ you might see कि this will put too much load on these guys. root server पे बहुत load आ जाएगा, edu server पे बहुत load आ जाएगा, because everyone in the world will be doing these translations. So so this way of resolving that the host name is called a recursive DNS query. यहाँ से recursion चल रही है, ठीक है. Normally we don't have the recursive method. What we have is iterative method. Okay, in the iterative method, you send the request to your local DNS server. Local DNS server, if it doesn't have the answer, will ask the root DNS server. बट रूट से कभी पूछेगा नहीं, इसके पास शायद .edu का भी कैश हुआ होगा. सो लेकिन अगर नहीं कैश हुआ हुआ तो रूट से पूछ लेगा, और फिर उसके बाद .edu से पूछेगा, एंड देन द .edu will respond with the IP address of the name server of the nyu.edu domain, and then this guy will ask the nyu.edu, which will make this translation, and this guy will respond to my DNS client, which is part of my browser. तो ब्राउजर को जो है ना आईपी एड्रेस मिल जाएगा. इस सारी तकलीफ के बाद ब्राउजर को सिर्फ आईपी एड्रेस मिलेगा. अभी उसने राब्ता नहीं किया, उसके बाद टीसीपी कनेक्शन एस्टैब्लिश करेगा nyu.edu से, उसके पास वेब रिक्वेस्ट भेजेगा, ठीक है. So this is part of what we call the iterative query. So so DNS protocol is very simple. Query and reply messages both with the same message format. एक ही message format है, और इसके लिए RFC में इसकी डिटेल दी गई है. There is another set of slides that I have uploaded. वो हमने अपलोड कर दिए, वो ऑथर की स्लाइड्स हैं चैप्टर 2 की. सो टेक अ लुक एट दोज. उसके अंदर भी ये फॉर्मेट जो है ये ब्रीफली डिस्क्राइब की गई है एक स्लाइड के अंदर. सो क्लाइंट सर्वर इंटरैक्शन इज happening on UDP port 53. If you guys have done the zeroth programming assignment, then you probably would know that UDP will be using port 53. TCP को support करते हैं, but not implemented. Almost always जो है UDP इस्तेमाल करते हैं इसमें. So scalability के point of view से, if you look at it, you have many names, many updates, many users. We can all support that, and it is highly available. Per domain availability, DNS servers, as we had said, are replicated. There are primary and secondary name servers. So if you look at the network configuration in your machine, you will see 2 DNS servers. So primary and secondary DNS servers. You will contact the primary one. If it doesn't respond or fails, then you will contact the secondary DNS server. So the name service is available if at least one of the replica is up. Okay, and the queries can also be load balanced between the replica. Okay, you try the alternate servers on timeout, and if you time out, then you do what we call exponential backoff, which means that you double the time before you can send the request again. Okay. So so we also don't want any kind of naming conflicts and consistency, which is again given by the is maintained by the DNS server, is offered by the DNS server. And the lookups are fast. Maybe lookups are not so fast. You have to contact the NYU server before you get an answer. But mostly DNS request responses, they are cached. They are almost cached always. Okay, so caching of DNS responses happens at all levels, just to make sure that the responses are fast. This reduces the load, also reduces the load at all levels, and also reduces the delay experienced by the DNS client, which is by the way very important. So DNS caching, how does that work? DNS servers cache the responses to the queries. Responses include the time to live field. Server will delete the cached entry after the TTL expires. So now you see that why that TTL was included, because you wanted to cache the response. And after the TTL expires, then you will delete the cached entry. So the caching is effective because the top level servers are very rarely change. Root servers, they almost never change. TLD servers almost never change. popular sites are visited often. So www.cnn.com और बहुत सारे सर्वर उसके अंदर होंगे, visited very often, visited very often. So LUMS ने उसको कैश करके रखा हुआ होगा. So local DNS server, local DNS servers, they often has the information cached. तो मुझे हो सकता है कि यहीं से LUMS के अंदर से ही जवाब मिल जाएगा, बाहर उसको किसी से पूछने की जरूरत ही नहीं होगी. Okay. Now there are, whenever you have a big, large distributed system, there are vulnerabilities. There are vulnerabilities. There are many ways one can attack the DNS. One can attack the DNS system. One can attack the DNS system. A couple of ways we will just quickly exemplify those. So let's say you have a local DNS server and you have a DNS client. One possible way that you can exploit the DNS server is you can attack the DNS server is basically so you want this name translation www.epfl.ch. Okay, you send this query to local DNS server, but somebody else on the network, this impersonator on the network sees your query, and instead of this local DNS server replying, this guy will reply first and will give you 1.1.1, which is an incorrect translation. कोई incorrect translation उसने दे दिया आपको, and you will think that it is the correct translation. You will contact 1111, and then maybe you will be served some page which is not what you intended to see. Okay, so one is you can impersonate the local DNS server, give the wrong IP address to your DNS client. The other way that you can attack the DNS is by overloading some of the servers. So for example, you have a DNS client which asks the local DNS server, which may ask the root DNS server, the TLD server. So you want some translation. So if the local DNS server does not have the translation, then they will contact the root DNS server. By the way, those are cached. So TLD वाले edu TLD भी cache हुआ होगा. तो अगर cache नहीं हुआ होगा, तो they will contact them. So somebody, this denial of service attacker, it's not the impersonator. This is a denial of service attacker. This will send huge amount of traffic to the root DNS server and the TLD DNS servers. This kind of an attack, what it will do is that this guy will make the root DNS servers very busy, TLD servers very busy, and these guys will not be able to respond to your local DNS servers in time. Okay, the attack, the denial of service attack on root DNS server has not happened yet. For TLD servers, this people have tried to do that, not very successfully though. There have been some instances though, when because of the DNS, because you think about it, DNS is like if you don't have the name translation, you can't contact the guy. So it's really central to all the networking communication. Okay, so it has happened rarely though that TLD translations have been impacted because of the denial of service attacks. More recently, I think a couple of years ago, 2-3 years ago, using the IoT devices, people were able to launch huge amount of traffic, and they were able to overwhelm the TLD servers, who were not then able to respond to the local DNS servers. Okay? So so impersonation and then denial of service. Okay? There is another way that you can attack, and by the way, many more ways. We don't have an exhaustive list here, but another way that you can attack the DNS system is you have a DNS client which requires translation from the local DNS server. Now, somebody here, this Kasha guy, what this guy does is, instead, it's not an impersonator, it's not a denial of service attacker. This Kasha guy is a cache poisoner. So this local DNS server, my local DNS server has a cache. This Kasha guy can go and poison the DNS cache somehow. ठीक है, इसको poison कर देगा वो इस cache को, which will basically either increase the delay experienced by the DNS clients, or they will get the wrong answer. या तो poison करके वहां पे रॉन्ग एड्रेस डाल देगा या पॉइजन करके वहां से एंट्री कोड आ देगा, विच मींस कि उसको बार बार फिर रूट से TLD से लेकर आनी पड़ेगी. Okay. So this is all about DNS. To wrap it up, DNS provides indirection. Addresses can change underneath. Name could map to multiple IP addresses. This is different from Anycast, as we explained. Name could map to multiple IP addresses. In the case of Anycast, name will translate to one IP address, and that IP address will be given to multiple machines on the internet. Everyone will claim to have the same IP address. So multiple names for the same addresses, multiple names for the same addresses. You can also have that. So this allows the host names to evolve into what we call service names. Host names जो हैं वो आपके service names बन जाएंगे. mail.lums.edu.pk or lms.lums.edu.pk. These hosts, they actually will become, these are services which are offered to you. zambil.lums.edu.pk, student management is done through that. Okay. So this was all about DNS. Very quickly, I'm going to talk about two more protocols at the application layer. One is the file transfer protocol, which is a very primitive, old kind of a protocol still used. It's supported by most of the browsers, almost all the browsers. And then the SMTP, used very often, which is simple mail transfer protocol. Mail transfer protocol. Whenever you send an email, the email under the wraps, it's using the SMTP protocol. FTP is used less often these days because file transfers are increasingly happening by using the HTTP protocol. Remember, HTTP protocol was designed for web pages only. FTP was for generic files. But these days, HTTP is used for downloading generic files as well. So in that sense, the utility of FTP has decreased quite a bit. So I'm going to open this other slide. These other slides. Let me just go ahead and open that. So by the way, these slides are from chapter 2 and these are author slides. I have modified these a little bit. इनको हमने थोड़ा over the years modify किया हुआ है, myself and Dr. Tariq. And these slides are also uploaded on the LMS. You will see a lot of duplication from the content that we had already covered. तो ये हम दोबारा से तो नहीं cover करेंगे, but these slides are there definitely for your reference, for reinforcement. जो आपने चीजें पहले पढ़ी हुई हैं. So FTP, I'm just going to quickly talk about FTP here. How do I share now? Let me just share this screen here. FTP. There. Okay. So people can see the screen. Shared screen नजर आ रही है आप लोगों को? Yes. Okay. Sure. Great. So what FTP is doing, again, it's a client server kind of a model. You have a client just like in HTTP. So you have a FTP client on the left, and this FTP client, and this FTP client will send a request for a file to this FTP server, and the server will oblige. There will be remote file system on the server, just like in HTTP. वहाँ पे भी remote file system होता है, और remote file system से आपके पास web file, HTTP file, HTML file उठ के आ जाती है, या other resources, other objects आ जाती हैं. And then there is the local file system. So file transfer protocol will copy the file, transfer the file between these two file systems. By the way, HTTP is typically, although you can upload the files by using HTTP, server भेज देते हैं, लेकिन ज्यादातर किस लिए इस्तेमाल होता है? ज्यादातर इस्तेमाल होता है get करने के लिए files, ठीक है? You can of course post the files as well, but FTP is used for sending files in either direction. once again, again using HTTP, you can do that. You can send the file from client to server as well, but it's not, originally it was not meant for that. It was not meant for that. It has expanded over the years to include this functionality of sending the file from client to server as well. So that's why the utility of FTP has decreased. So FTP is used for transferring the files to and from the remote host. Okay, uses the client server model. The client is the guy which initiates the transfer. चाहे फाइल भेजनी हो चाहे रिसीव करनी हो, क्लाइंट वो होगा जिसने कनेक्शन इनिशिएट किया है, जिसने इंटरेस्ट शो किया है दैट आई वांट टू रिसीव द फाइल और सेंड द फाइल. It doesn't matter whether you want to send the file or receive the file. You will be the client if you have initiated the interest in communication. Okay, so this is covered in RFC 959. Remember हमने कहा था कि HTTP runs on port 80. FTP HTTP by default runs on port 80. You can run it on any other port as well. So FTP server, it runs on port 21. It runs on port 21. Yeah, port 21 पे ये run करता है. Now, in the case of HTTP, we said that there is a TCP connection that you have to first establish. First, you have to establish a TCP connection, and then you can do HTTP on top of that TCP connection. So transport layer पे ये secretaries अपना TCP establish कर लेंगे. उसके बाद CEO, vice president, president, they will be able to send the data. FTP does the same things. Again, it requires underneath it requires TCP. क्योंकि file transfer में you want to replicate the file from client to server or server to client exactly bit by bit. उसी तरह replicate करनी है. We can't afford the loss of a bit or a packet. तो इसलिए UDP नहीं यूज कर सकते underneath. Transport layer पे you will need to use TCP. TCP को यूज करना पड़ेगा. So FTP server runs on port 21, okay, and FTP protocol underneath will use TCP. It uses not just one TCP connection, it actually uses two TCP connections. ये किस लिए? दो TCP connections क्यों इस्तेमाल होते हैं? Well, two TCP connections इस्तेमाल होते हैं. One is for sending the control commands. It's called the TCP control connection, and the other is used for sending the data, actually sending the data. HTTP में ऐसा नहीं था. वहाँ एक ही TCP connection था. रिक्वेस्ट उसी पे जा रही है, उसी के अंदर आपके सारे जो कुछ आपने इंफॉर्मेशन भेजनी है चली जाएगी, उसी टीसीपी कनेक्शन पे रिस्पांस भी आ जाएगा. यहाँ पर कंट्रोल कमांड्स आपकी एक टीसीपी कनेक्शन के ऊपर जा रही हैं एंड डेटा द फाइल विल बी ट्रांसफर्ड ऑन अ सेपरेट टीसीपी कनेक्शन. इसको हम ये भी कहते हैं कि आउट ऑफ बैंड सिग्नलिंग हो रही है. आउट ऑफ बैंड सिग्नलिंग हो रही है. व्हाई? बिकॉज यू हैव फॉर सिग्नलिंग और फॉर कंट्रोल यू हैव a separate TCP connection. So FTP client will contact the FTP server at port 21. ये port 21 पे उससे contact करेगा, which means the server will have a port 21 running here. Okay. Now, once this first TCP connection, first of all, you will establish this control connection, TCP control connection. Okay. The client is authorized over the control connection. The client browses remote directory. अभी तक कोई डेटा कनेक्शन नहीं एस्टैब्लिश हुआ है. द क्लाइंट ब्राउजेस द रिमोट डायरेक्टरी एंड सेंड्स द कमांड ओवर द कंट्रोल कनेक्शन. वो कमांड्स भेजता जाएगा कंट्रोल कनेक्शन के ऊपर. जब वो कहेगा कि मुझे एक फाइल चाहिए, व्हेन द सर्वर रिसीव्स फाइल ट्रांसफर कमांड, वो जब क्लाइंट उसको कहेगा भाई मैंने अब फाइल भेजनी है या रिसीव करनी है, गेट और पुट करनी है, द सर्वर विल ओपन द सेकंड टीसीपी डेटा कनेक्शन. जो सेकंड टीसीपी कनेक्शन खोलेगा, वरना एक ही के ऊपर सब कुछ हो रहा होगा. फाइल की लिस्ट देखनी होगी या कुछ भी, वो एक ही के ऊपर होगा. बाय द वे, वो लिस्ट जब देखेंगे तो वो डेटा कनेक्शन के ऊपर आएगी, द लिस्ट इटसेल्फ. ओके, so the second connection will be opened when the client actually wants to transfer some data. ठीक है. And to open this data connection, you will use server port 20. सर्वर की साइड पे port 20 होगी. Now, server initiates this connection. सर्वर को कैसे पता चलेगा? सर्वर को कैसे पता चलेगा कि मैं क्लाइंट की कौन सी पोर्ट इस्तेमाल करूं? यहाँ पे on the left side, which port of the client should be used? By the way, when you open a TCP connection, you have ports on both sides. You have IP addresses on both sides. Okay? So TCP connection is a four tuple. IP addresses on both sides, client server, machine A, machine B, ports on both sides. The port on the client side is picked randomly by the operating system, या वो incrementally जो है वो अपने operating system के बाद जो free port होती हैं वो इस्तेमाल करता जाता है, ठीक है. But you have to have a port. Now, when you establish a connection, you need to know the port of the server. क्लाइंट ने तो अपनी पोर्ट कोई सी भी चूज कर ली है, लेकिन सर्वर की पोर्ट पता होनी चाहिए, तभी तो आप उसके साथ कनेक्शन एस्टेब्लिश करेंगे. तो सर्वर ने यहाँ पे अपनी पोर्ट 20 से एक कनेक्शन एस्टेब्लिश करना चाहा, टीसीपी डेटा कनेक्शन एस्टेब्लिश करना चाहा. Which port it will use on the client side to make that connection? Anyone who can make a guess? ये सर्वर को कैसे पता चलेगा कि क्लाइंट साइड पे कौन सी पोर्ट है जिसके साथ मैं टीसीपी डेटा कनेक्शन एस्टेब्लिश करूं? एनी टेकर? कोई जवाब देना चाहता है? Nobody wants to answer? Okay, that's fine. Okay, the way that the server will find out which port on the client side should be used, that information will be sent over the TCP control connection. TCP control connection पे ये भेजी जाएगी. तो ये client जो है सर्वर को बताएगा कि भाईजान मैंने ये एक पोर्ट अपनी अलग कर ली है. If you want to establish a new TCP connection अब data transfer के लिए TCP data connection establish करना चाहते हैं, so here is the port, use that port. तो now you might guess कि यहाँ पे ये जो आप जिसको हम FTP क्लाइंट कह रहे हैं, ये बेसिकली यहाँ पे एक सर्वर अपना रन कर रहा होगा, एक सर्वर का कोड रन कर रहा होगा, जहाँ पे वो एक सर्वर जो है डायनामिकली जो है वो स्टार्ट कर देगा उस पोर्ट के ऊपर, जिस पोर्ट के ऊपर वो चाहता है कि ये FTP सर्वर उससे कांटेक्ट कर. So the server will open the TCP data connection to transfer another file. The control connection is called out of band. FTP server, by the way, maintains the state, current directory, earlier authentication, वो उसको maintain रखता है जब तक control connection को खत्म ना कर दिया जाए. Okay? So transfer of file on one data connection, फिर वो data connection खत्म हो जाएगा, अगली फाइल के लिए एक अलग data connection establish होगा. Control connection जो है वो same ही रहेगा. Control connection same रहेगा. So FTP की कुछ commands and responses. By the way, you can play with these commands by using the command prompt window. Windows या Linux या Mac अपने operating system में you can get the command prompt के ऊपर जो है you can send these commands. FTP commands ये भेज सकते हैं. So username, password, list will send you the list of the file in the current directory. Retrieve the file, store the file. These are the commands that you can actually use. You manually इसको करके देख सकते हैं. Then there are some sample return codes. कुछ return code आते हैं बिल्कुल इसी तरह जैसे HTTP के अंदर थे. ये return code कुछ उसमें error warnings आएंगी और कुछ जो हैं वो okay वाले होंगे कि ठीक है ये फाइल आपको भेज दी. So now I'm going to very quickly, in the last 5 minutes, talk about the electronic mail. Next lecture we will cover the peer-to-peer applications. Okay. So today I'm going to just talk about electronic mail, maybe in the last 5-6 minutes. So electronic mail is basically when you send the mail from your machine to another, from your machine to another guy, who can read the email somewhere else. Everyone will have a mailbox. आपके पास एक mailbox होना चाहिए किसी mail server के ऊपर. वो mailbox किस लिए होना चाहिए? वो mailbox इसलिए होना चाहिए कि वो आपके लिए emails receive करेगा. Because you are not always on. हमेशा available नहीं होंगे. So whenever you are offline, mostly, then there has to be somebody on your behalf who can receive the email for you. कोई secretary होना चाहिए आपके पास जो आपकी emails जो है वो receive करता रहे. And this mailbox does that job for you. ठीक है? So when you want to make sure that you are able to receive the mail, you have to have a mailbox on some server. So you will basically have an account on some mail server. So for example, Lums has a mail server. Lums ने तो Microsoft पे host किया हुआ है, लेकिन नॉट नेसेसरीली हर ऑर्गेनाइजेशन माइक्रोसॉफ्ट पे होस्ट नहीं करेगी, वो अपना इंटरनली भी होस्ट कर सकते हैं. प्रीवियसली लम्स यूज्ड टू होस्ट लोकली, अपने पास इनके पास मेल सर्वर होता था. उस मेल सर्वर के ऊपर सारे यूजर्स को, सारे स्टूडेंट्स को, फैकल्टी, स्टाफ, सबको जो है वो एक एक अकाउंट मिल जाता था. और वो अकाउंट का मतलब ये है कि आपको एक मेल बॉक्स मिलेगा. वो मेल बॉक्स किस लिए होता है कि पूरी दुनिया से कोई भी आपको मेल भेजना चाहे वो आके उस मेल बॉक्स में होगी, एंड यू कैन रिट्रीव दैट ईमेल व्हेनेवर यू वांट. तो जब भी आपका दिल करे उस अपना ईमेल क्लाइंट को यूज करें और अपने मेल बॉक्स से वो ईमेल पढ़ लेंगे. ठीक है. नाउ you will also need an account on a mail server because you want to send the email as well. आपने ईमेल सेंड भी करनी है तो आप डायरेक्ट अपनी मशीन से सेंड नहीं करेंगे. You will send the mail through these mail servers. तो हर मेल सर्वर के ऊपर आपका अकाउंट होना चाहिए. By the way, if you don't have an account on a mail server, there are some what we call open relays which are available on the internet. थोड़ी तलाश करनी पड़ती हैं. They allow you to send the email to anyone. तो anonymous email आप लोग भेज सकते हैं किसी को अगर भेजनी हो by using the open relays. ठीक है. सो लेकिन सोच समझ के भेजें, वो पता चल जाएगा कि किसने भेजी है ईमेल. इट्स चैलेंजिंग, लेकिन अगर कोई ऐसी ऐसी ईमेल भेज दी तो वो पकड़ लेते हैं, पता चल जाएगा उनको. सो एनीवेज, so the way that electronic mail, what are the protocols underlying electronic mail? So when you are sending the mail from your machine to the mail server, we use a protocol which is called SMTP, Simple Mail Transfer Protocol. ठीक है. तो ये जिस सर्वर को आपने भेजी है, नॉर्मली दिस वुड बी द सर्वर ऑन योर कैंपस, ऑन योर ऑर्गेनाइजेशन. ठीक है. ये मेल सर्वर होगा जिसके ऊपर आपका अकाउंट बना हुआ है, जिसके ऊपर आपका इनबॉक्स भी है. इनबॉक्स मेल बॉक्स है जो रिसीव करता है मेल. सो जब आपने भेजनी है मेल तो उसी मेल सर्वर के थ्रू भेजेंगे. बाय द वे, दिस फॉर सेंडिंग एंड रिसीविंग यू कैन हैव टू डिफरेंट मेल सर्वर्स. रिसीविंग के लिए आपके पास मेल बॉक्स होना चाहिए, सेंडिंग के लिए आपके पास मेल बॉक्स की जरूरत नहीं है. बट टिपिकली क्या होता है कि एक ही सर्वर के ऊपर आप सेंडिंग रिसीविंग दोनों एक ही सर्वर के थ्रू कर रहे होते हैं. सो दिस मेल सर्वर, let's first focus on sending the mail. This mail server that you are using to send the mail, you will send the mail using SMTP from your machine to the server. अपने लोकल सर्वर को भेज दी, लेकिन ईमेल तो आपने किसी और को भेजी थी, john@nyu.edu को भेजी थी. So your local mail server will establish a new TCP, a new SMTP connection. By the way, SMTP will also use TCP underneath, क्योंकि मेल ट्रांसफर करनी है, उसके अंदर भी एक बिट भी इधर से उधर नहीं हो सकती, एग्जैक्टली वैसी जानी चाहिए. सो SMTP is also an application layer protocol which uses TCP underneath. So SMTP आपका वाला जो सर्वर है वो रिमोट सर्वर से राब्ता करेगा, वो कहेगा यार ये मेरे पास ईमेल है, ये मैंने आपको भेजनी है. तो SMTP will be used for sending the email from your client to your server, and then from your server to remote server. वहां तक चली गई. रिमोट सर्वर क्या करेगा, उसके पास जॉन का मेल बॉक्स पड़ा हुआ है, वो जॉन के मेल बॉक्स में वो मेल डाल देगा. ठीक है. वो जॉन तक नहीं भेजेगा क्योंकि जॉन तो हो सकता है ऑनलाइन हो ही ना, तो वो अपने पास मेल बॉक्स के अंदर स्टोर कर लेगा. ठीक है. नाउ व्हेनेवर जॉन वांट्स विल गो टू द मेल बॉक्स एंड यूजिंग सम अदर प्रोटोकॉल, ईदर POP3 और IMAP और HTTP, वो अपनी मेल जो है वो मेल बॉक्स से उठा लेगा. ठीक है. So very simple. If I am sending a mail to John at newyorkuniversity.edu at nyu.edu, I will use SMTP. I will use SMTP to send the mail to my mail server. My mail server will use SMTP to send the mail to John's mail server at NYU. और उसके इनबॉक्स के अंदर डाल देगा, मेल बॉक्स के अंदर डाल देगा. And John will use the HTTP client और POP3 client और IMAP client, अपना कोई सा भी एक क्लाइंट यूज करेगा और वो अपने मेल बॉक्स से वो मेल पुल कर लेगा, और एट हिज ओन कन्वीनियंस. ठीक है. सो इफ यू थिंक अबाउट इट, sending the email from my machine to John's mailbox, it is a push mechanism. I am pushing the email. HTTP में pull होता था. I wanted to pull the information. I wanted to pull the HTML file stored on the server. In this case, I am pushing the mail to John's mailbox. So electronic mail में these are the few protocols. SMTP is the central to that, and then POP3, IMAP, and these days more prevalently HTTP is used for receiving the emails. So three major components are user agent. User agent is basically the piece of software which is running on your machine, जो आपका client है, and then the mail servers, you will have an account on a mail server, and then the SMTP. ठीक है. Another fourth component which is important, वो यहाँ slides में नहीं है, another fourth component which is important is the access protocol. यानी मेरे मेल बॉक्स में मेल पड़ी हुई है, मैंने उस मेल को एक्सेस कैसे करना है, और वो एक्सेस के लिए आपके पास POP3, IMAP या HTTP कुछ भी यूज कर सकते हैं. ठीक है. So the user agent or mail reader, your mail reader will be used for composing or editing and reading the mail message. So बहुत सारे उसके हमारे पास सॉफ्टवेयर अवेलेबल हैं. आउटलुक है, थंडरबर्ड है, आईफोन का मेल क्लाइंट है, आईफोन के ऊपर डिफरेंट मेल एप्स, जीमेल के लिए एक मेल ऐप है. You can, by the way, configure that Gmail mail app to connect to other mail servers as well. So outgoing and incoming messages are stored on the server. Okay. So outgoing messages are stored very temporarily. Incoming messages are stored indefinitely whenever you need them. ठीक है. So outgoing messages जो है सिर्फ temporarily store होते हैं, तो आपको वहां पे account होने की जरूरत भी नहीं है. So mail servers, they will have a mailbox containing the incoming messages for the users. They might have a message queue for outgoing mail messages, and then they will implement the SMTP protocol between the mail servers to send the messages. By the way, जो आपका mail server होगा, वो sending mail server होगा, वो एक client के तौर पे काम करेगा, और receiving mail server जो है, वो एक server के तौर पे काम करेगा. So electronic mail uses the TCP and port 25. There is a direct transfer, sending server to the receiving server. The three phases of transfers include the handshaking, the actual transfer of messages, and closing the connection. So opening the connection, which includes the greeting, then transfer of the message, and then closing the connection. Very, very simple mechanism. Okay. All the commands in SMTP in SMTP protocol, these are in ASCII. ASCII text होती है ये command. Status code और phrases जो हैं वो भी ASCII के अंदर है. So all the message must be in 7-bit ASCII. But imagine you want to send an image file. Image जो है वो तो ASCII में नहीं होता. Then underneath somebody will translate those images, जो binary file होगी उसको ASCII के अंदर convert करेगा, और वो ASCII characters सिर्फ जाएंगे. पुराने ज़माने में क्या होता था कि the images that you would send, उनको आपको मैनुअली एनकोड करना पड़ता था ASCII के अंदर, और फिर रिसीविंग एंड के ऊपर मैनुअली डिकोड करना पड़ता था रिसीविंग एंड के ऊपर. ओके, बट दीस डेज एवरीथिंग इज ऑटोमेटिक. Images will get translated into corresponding ASCII stream. So again, same mechanism, me sending an email. So I will have a user agent using SMTP protocol. I will send the mail to my mail server. उसे कहूँगा भाई ये दूसरे एंड के ऊपर भेज दें, and then this mail server will again use SMTP to send the mail to remote mail server, और remote mail server के ऊपर मेल बॉक्स के अंदर डाल देगा. किस मेल बॉक्स में डालेगा? जॉन के मेल बॉक्स में डाल देगा जिसको मैंने मेल भेजी थी. ठीक है, इनफैक्ट बॉब के. सो बॉब को अगर ईमेल भेजी है तो बॉब के मेल बॉक्स में डाल देगा, एंड देन बॉब जब तक ऑनलाइन नहीं आएगा वो मेल बॉक्स के अंदर उसके मेल पड़ी रहेगी. व्हेनेवर बॉब कम्स ऑनलाइन, अपना ईमेल क्लाइंट, अपना यूजर एजेंट जो है वो ऑन करेगा, और वो ये नंबर 6, बॉब इन्वोक्स हिज यूजर एजेंट टू रीड द मैसेज. तो वहां से अपना मैसेज जाके वो पुल कर लेगा. ऑल द वे from this user agent all the way to Bob's mail server. This is pushing of message. So this is a sample SMTP interaction. I will leave it there. You can also try this SMTP interaction yourself. कोई server name कोई तलाश करें, mail.mit.edu, उसको telnet करें from the command prompt window, and then you can probably see some of the interaction. So SMTP uses persistent connections. SMTP also requires the messages to be ASCII. carriage return line feed इसके end करने के लिए इस्तेमाल होती है. And the comparison with HTTP, as we had explained, that HTTP is pulling the HTML file, SMTP is pushing the message to the mailbox of the recipient. Okay? Both have ASCII command responses. HTTP में each object is encapsulated in its own message response. Okay? In the case of SMTP, multiple objects are sent in a single message, but that message can have multiple parts. Okay? So generally you have this header of the email, and then the body of the email. Header and the body of the email described in a very old RFC, which is 822, has not changed much. Okay? So you have between user agent and sender's email server, you have SMTP running. Between the sender's email server and the receiver's email server, sender's email server and receiver email server, you again have SMTP. And then you have a mail access protocol, POP, IMAP, HTTP, इनमें से कोई यूज करके जो रिसीविंग पार्टी है वो अपनी ईमेल पढ़ सकती है. जब तक वो नहीं पढ़ेगी वो उसके मेल बॉक्स में पड़ी रहेगी, उसके मेल बॉक्स में पड़ी रहेगी. So here is an interaction of POP3 protocol. The difference between POP3 and IMAP is again POP3 is a very simple protocol. क्या करता है ये कि आप जाते हैं और अपने messages जो है वो retrieve कर लेते हैं एक एक करके. If you want to delete those messages, you will delete those messages. Once you delete the message on the mail server, you cannot read those messages by using another mail client. आप किसी और machine से login होके फिर तो वो message नहीं पढ़ सकते. ठीक है ना. तो POP3 में if you delete the messages on the mail server, then those messages are gone. You cannot use a client. मेरे पास एक डेस्कटॉप है, एक लैपटॉप है. डेस्कटॉप से मैंने जाके POP3 को यूज किया, मैसेज डिलीट कर दिया, इट्स गॉन. लैपटॉप से अगर मैं एक्सेस करूंगा तो वो मुझे मैसेज नहीं नजर आएगा बाय द वे वहां पे. IMAP on the other hand is a more complex protocol. What it does is ये आपका जो मेल बॉक्स है वो सर्वर वाली साइड के ऊपर है. ये सारी मैनिपुलेशन आपको सर्वर पे करने की इजाजत दे देता है. which means the messages they will stay on the server. या डिलीट अगर करेंगे भी तो सर्वर से ही डिलीट होंगे, and they will be deleted for everyone. But really you can do all the manipulation of the messages on the server side. वहां पे फोल्डर क्रिएट कर दें, जो मर्जी कर दें, ये आप सर्वर साइड के ऊपर कर सकते हैं. By the way, I would like to you to think about कि modern day email services जैसे Outlook 365 है, they are also built upon these POP3, IMAP, SMTP. ये कहीं ना कहीं ये use कर रही हैं. So try to think about कि how these services are using these protocols and try to relate to the modern day email services based on Gmail and Outlook 365. So that finishes the discussion on on email. Next time we will talk about the peer to peer application. अभी तक हमने जो डिस्कशन की है वो सारी क्लाइंट सर्वर टाइप की एप्लीकेशंस थे. These are all client server type of applications. HTTP client server, SMTP client server, FTP is client server, DNS is client server. But next time we'll talk about peer to peer. Skype is peer to peer. Zoom is peer to peer. Zoom is peer to peer. Okay. BitTorrent is peer to peer. File transfer के लिए इस्तेमाल होता है. So we'll have P2P applications covered in the next lecture, and then the next week we will talk about the transport layer protocols, which would be chapter 3, by the way. Chapter 3 की slides जो हैं वो भी हम upload कर देंगे in due time. Okay. So any questions before we leave? Any questions? कोई question नहीं? So I'm going to close the session now if there are no questions. Thank you so much. Khuda Hafiz.